Hey there all, we're going to be doing another LeetCode question. This one is called binary tree right side view. So let's read the problem. You're given the root of a binary tree. Return only the values of the nodes that are visible from the right side of the tree, ordered from top to bottom. I did encounter this question before and I was so confused on how I would implement the solution. I thought that, I just go traverse down and return all the right the right nodes. And it did pass the 2 test cases that I was given, but it didn't account for everything, and I think I know why. The reason for that is because, say for example, this node over here does not exist, we'll have to get number 6, which is on the left side. It's not node dot right. And if, let's say, there's another level here, well, that's what we have to return. It's basically envisioning that this binary tree is like 3D and then just observing it from the right side. Which nodes would you see on that plane? And DFS does not work, but I just thought of an amazing idea. We're going to be using BFS, so we're going to be doing just that, collections.deque. I think this is the queue in Python. Sorry, I don't remember the syntax. This is heaps I can kind of understand, but not really. Okay, so I'm right. Okay. We're gonna initialize a queue and we're gonna use BFS to traverse through each level, except we're only gonna be returning the appending the nodes at the very rightmost. So let's do just that. This is the thing. This is the list which we will be appending the answers to, and we can go ahead and do that. Well, first of all, let's append the root, and let's begin. Let's use DFS. While queue, for I in range len queue, if for node, right? If node queue dot append node dot left, and we also add the right node. This is also a pretty good way of practicing my BFS. So we basically add this, and then we're traversing by levels. So we add left and right, and then what do we want to do? We want to get the last item in the list. I feel like I need to a way to keep track of what the last value of the node is, because that's what we're appending. So I feel like I should actually use enumerate here. No? So now we're gonna get the index and the node value itself. If I is greater than or equal to len q, would it be len q? I plus 1 though. How do I get the last value here? I would be, say we have q, just 1, 2, 0, 1. Yeah, it should be like this. Then we append the node itself. Or do we append the value? Okay, the value. Okay, so we do that. And this should keep like looping. Oh wait, I should actually pop from the queue. Queue dot pop left. So I think it might be better if I do for I in range len q. node is equal to q.popLeft. Oops. If node, then we can do all this stuff. And if I plus 1, I can even do like I is equal to like len q minus 1. No. It's like the very last index possible. Let me actually print I and len q as well, because I do not know. Print len q. Print q, actually. Let's just print q. It's just to help with debugging. Added. So we're using BFS, but we're only adding in the value at the very end. Not sure if I implemented it correctly though. Okay, yeah. None type. Okay, so what is this, bro? Damn. So okay, can I like q dot values? Would that do anything? If not, then it doesn't really matter. Nope. Okay, whatever. Let's do this. Okay. Length of 1. Why am I not adding it though? So I is equal to 0 if node, oh, it's because I popped it. Okay. I should do this, and nice. Oh, damn. What's going on here? My output is a 1, but I'm expecting it to. Okay. Why is that? So I do know the length is a 1, and we add it. This is per level, by the way. Why is there 2 levels here? 1, 2. Does this work, bro? Nope. I'm pretty sure my approach is correct, but I just don't know the syntax. I might be I might be appending the what the heck? This might be none, dude. Yeah. Okay. I mean, I'm pretty sure. Dude, this is a lot of if statements and I don't like it, but whatever. Left. Dude, I'm pretty sure this will work, but there's gotta be a better way of writing this. Yes, okay, nice. I got this, but this is so messy. And this has a time complexity of O of n, where n is the number of nodes in their tree, and space complexity of O of n as well. It'll be at most like the whole tree. Yep. Now, why? Okay. DFS. Oh, you can do this DFS. Depth. If depth is equal to length, that's right. Okay, so you're using okay, so it is possible to do this with DFS. Just didn't know how to implement it. So you could like keep track of the depth. That makes sense. And where's the appending? Okay. If not node, if depth is equal to len res. Res the append val. I feel like this makes the most sense. Yeah, I could write this better though. Res q dot collections dot deque. Oh, I guess I can just immediately deque, huh? I don't even need this collections. Deque root, just like that. Interesting. While q length, and I guess to keep track of the right side, I initialize it to none first. This way we don't need to do this weird solution that I'm doing right here, where I'm doing this. I can do right side is equal to node, and then yeah, this won't matter because as we're going through this, right side will naturally be node. So as long as it's not none, right side, we can just press append right side. Okay, I see. DFS, no, BFS is more intuitive for me, but SQLN would be better. No. What? I don't even need QLN. Oh, I got it wrong. Why? Oh, that's why. There you go. Nice. Let me see this. Why this works and how can I like understand this? Node depth. If not node, return none. Okay. If depth is equal to length res, I guess length res is like, oh, do we have an answer for this depth already? Then we append it, but we go right first. So I guess this is how it goes down. What solution does Fire's NeetCode use? Keep in mind, okay, he uses the BFS. All right, I'm just using this to kind of just see what solution he uses. But I already got it. You hear me, AI? AI summarizer? Yes, okay. Now, this makes the most sense. Alright, that should be it. Wow, I'm getting better at this. I'm like doing this fairly quickly. Alright, see you next time.